Good day, everyone. We are still with applications of differentiation in maths level 4. Now we'll be looking at problems of distance, velocity, and acceleration. So they are very simple problems, so we'll go through this one. It says an object is projected vertically upward and its movement is given as s equal to. So this is the equation of motion of the object, where s represents distance in meters and t is time in seconds. So the first part says we should determine the height at after 3 seconds. So that is very simple. So we start by taking the height equation because they said it's projected vertically upward. So s represents the height equation. So the height equation is 116 t minus 20 t squared. So that is our height equation. So all I need to do is to say at t equal to 3 seconds, I substitute in there, I will get my 116 into 3 minus 20 into 3 squared. Then I will see my height after 3 seconds. So that's how simple it is. So I'm getting my 116 times 3 minus 20 times 9, since 3 squared is 9. So that gives me my height as 168 meters. Once you punch that into your calculator, that is how simple it is. So with the A part, we are as good as done. Then we can go to the B part. So the B part requires the velocity after 3 seconds. So the challenge with this part of applications is that the formulas are not on the formula sheet for maths level 4. So students who do physical science have an advantage here because they know that for me to get velocity, I need to differentiate the distance once, the displacement equation once. So if I need velocity, I must differentiate that equation for displacement once. So if I do that, it means I'm differentiating that with respect to t. So if I differentiate, I'll get 116 for the first term minus differentiate t squared, give you 2t, the t will multiply negative 20 to give us negative 40t. So that is how simple our velocity equation looks like. So all I need to do is to check from here at t equal to 3, what is now my velocity? So my velocity will be 116 minus 40 into 3. So from there, I can consult my calculator to see what the answer will be. So I get 116 minus 40 to 3 is actually minus 120. So I get a negative. So when it comes to velocity as well as acceleration, when your answer is negative, you don't need to panic because velocity and acceleration are called vector quantities, which means they have magnitude and direction. So the negative is just indicating the direction to us. Remember, they said the particle is thrown vertically upward. So maybe when it's going upward, the velocity is negative. When it's coming downward, it's positive, just to show that there is change of direction. So that's how simple it is to get our velocity. You see, velocity is not just that easy. The only problem with level 4 is that the formula for velocity as well as acceleration, you will not see it on your formula sheet. So we can now go to the C part. It needs the acceleration. The acceleration, if we call it A, it requires you to differentiate the velocity, the distance or the displacement 2 times. So if you remember, we have differentiated the distance once to get velocity. So I have to go now into this and differentiate again. So if I differentiate this one again, you see the derivative of 116 will be 0, and now only differentiating there, and I'll get my negative 40 meters per second squared. So the unit of velocity is meter per second, acceleration is meter per second squared. So initial direction of motion. So that is how simple it is to calculate your velocity as well as your distance. So we can now go to the last part. The last part there, we'll be looking at how to get the maximum height. So when it comes to problems of maximum, it can be maximum of anything. Maximum height, maximum acceleration, maximum velocity. So usually I follow 3 steps. So whatever function that comes after maximum tells me that I must differentiate it and equate to 0. So that's my step number 1. My step number 1 will mean I differentiate the height equation and equate to 0. So that is the height equation. It is differentiated once already. So all I need to do is to equate this item to 0, which gives me 116 minus 40t equal to 0. So that's my step number 1. Step number 2, I will solve for the variable. The variable in this case is time, which is t. So if I'm solving, I will carry that function to the right. So I'll get 116 is equal to 40t. Then I divide both sides by 40. So my t will be 116 over 40. So that gives me the time taken to reach the maximum height, 116 divided by 40. That gives me 2,9. So I get 2,9 seconds. And therefore, from here, I can get the maximum height. So the maximum height means I will substitute this time into the original height equation. So therefore, my maximum height, if I choose to call it S max, it will be telling me that I will get 116 into 2,9 minus 20 into 2,9 all that square. So that should give me to my maximum height. So I get 116 times 2,9, then minus 20 into 2,9 square. So that takes me to 168,2 meters. So this is my maximum height. So guys, you see how easy questions of velocity, acceleration, and distance can be. Thank you very much.